rest won't be. Should turn off some more lights.
Sure.
I just want to talk a bit about this. Paul's real familiar with, it's not this part, but it's a part that looks a lot like it. Yeah, we just put in a new robotic grinding cell that takes castings, saws the gating off of them, and then grinds them complete. I've only got about half a dozen slides here, so there's not a lot. The general idea is that parts come in on this conveyor with all the gating on. And the gating on the part, you know, it's similar but not the same. Gating comes down on the side of the part, down on this side of the part, and enters into the cavity, and we tilt pour in this manner. So there's gating on three sides, and there's a lot of sawing that goes on, band sawing. Well, what we're doing with this new robotic cell is we're grinding the gating and sawing the gating off the part. So what happens?
Sorry, Wayne, I'm not as smart as the lighting.
Kevin had it figured out this morning. I don't know.
Yeah.
But so these parts have all the gating on. There's a long gate on this side of the part. There's a piece across the end, and there's a piece on the other side. So that's the infeed. There's a vision system inside this cabinet looking down at the part. It finds the part number. It gives it's a FANUC R2000 robot the coordinates. The robot goes and picks it up. Then it'll take it to the sawing, which I think we got some shots coming up here. And then finished parts come out all stacked up on this conveyor. And other than a little bit of handwork, the part is done. It goes to a machining operation subsequently, but all the gating is removed and ground.
Yeah, Wayne, you can only cut 1 section off at a time.
Okay.
Or I can turn the whole thing on.
Well, I would at least like these off. This is just another shot. You can kind of see more of the gating. There's the end gate here, the side gates. That's better. Ooh. I think I'm going to go back. Yeah, the colors look a lot better now, don't they? But yeah, now you can see the gating coming down here and across and over. Now if I can see my... It's a little hard to see what's going on here, but the parts, these are the finished parts, the raw parts are here, the vision system on top. Right back here is the saw machine. You can see the robot, the jointed arm robot. But there's a saw blade sitting up about this high on an angle, and the robot takes the part and feeds it by the saw blade. And the key to that is it's sawing repeatedly very close to the edge of the casting. When you're doing grinding on a robotic grind cell, how much metal you remove is a function of time. You know, you can control the force and all that, but it's really how long is that part in touch with the grinding belt. Well, if the gating is not sawed the same every time, you touch sooner and it'll start to grind, but it doesn't grind as much off because the part's thicker. So by sawing first in a very controlled manner, then you're controlling how much grinding you're doing. So the key there is getting it uniform coming into the grinding. And that's what the automatic saw does. This is just to show that all the gating comes out and falls into a hopper over there. So it's automatically removed out of the cell. So there's maybe a better picture of the saw. The saw is up here. The robot has one of these similar parts on the gripper. This is one of the finishing grinders over here. It'll grip the part on various features. It'll come over and grind. There's actually 2 finish grinders in the cell. And we're just running the PPAP on it right now, the approval process. And that is pretty much all I have here, just an overall shot of the cell. With the saw being way back there, one finish grinder here, the other finish grinder here. And what we're going to be doing is implementing new part numbers one at a time, hopefully 1 a month or something like that over the rest of this year. And we eventually want to run probably, 30 different part numbers across there. So.
Or more. You keep telling me you want to do more.
Yep. We want to tackle the ones that have the highest volume and have the best return for both of us. So it was an interesting project. That was our 3rd robotic grind cell that was integrated. It was the 2nd one for AKG. So looking forward to putting more parts on there. Increases the productivity of the trimming operation, and it increases the quality of the part. Very consistent, uniform grinding. So there's any questions, otherwise, thanks for coming.
Wayne, how many parts can run in that cell?
We're thinking probably 30 to 40 part numbers by the time we're all done. We've got another cell that was a family of 12 run in there. But more could run in this one. This one's more versatile with that sawing operation. And they don't have to be, that style part. With that end effector, there's an automatic tool changer. Well, not automatic, but there's a tool changer on there. So we can put an end effector for any part on there. And with the flat belt conveyor and the vision system, it doesn't cost a lot to implement each part number. That's the key, because sometimes the robot cells are very expensive to integrate, and how specialized the fixturing and the end effector gets makes the cost to set up an individual part very high. But with this, the parts just come in on a conveyor. The robot picks them up from a vision camera. That's flexible automation. You can program it to find a different part number, and the end effectors are, I don't know, they're not very expensive, a couple grand maybe, you could build an end effector. So that means that we can implement lower volume parts than maybe was the case 4 or 5 years ago. And that's the nature of this work. We don't make thousands of these per year. We make 1,500 maybe, something like that. So it's not maybe what you'd consider a typical robotic application. Usually the robot grind parts were the 50,000 a year, 60,000 a year. In this scenario, we've got a high number of parts, but not a high quantity of any one. So by utilizing again, the flexible automation, it makes it cost-effective to implement parts like that. Another application would be using a robot like that for loading CNC machines. We don't currently do that. Premier does that, where they have a robot tending a couple of lathes, and it automatically loads and unloads, and an operator runs a third lathe, right? So it's a cell of 3, 2 robotically tended, 1 manually tended. Another way of tripling your productivity. Right, well, if there's anything else, otherwise, thanks for coming.